Hey guys, welcome back to my YouTube channel. So for today's video we'll be making a not logic gate, and if you're new to my YouTube channel, first of all, welcome. And this YouTube channel is all about making some fun projects and doing some fun activities regarding with electricity. Like in our last video we actually replaced iPhone's battery, and trust me, it was a really amazing experience for me too. And if you want to actually watch that video, I'll definitely link it down below in the description. And if you're into all this electronic stuff and always wondering how our daily life essential electronics work, you should definitely hit the subscribe button, since it will keep you notified whenever I upload a new video. So before moving on further with the video, I would like to tell you that I have a Fiverr account. So it's basically a freelancing app, and I'm available 24/7 over there. If in case of any emergency, you have like any project or any activity coming up in school or college or anything, and you need just some instantaneous help, or if you even have some time and you just need to get one project done and also learn how that project or the activity which you're doing is actually the circuit actually working, you should definitely check out my Fiverr account. I have some really reasonable and affordable prices over there. I can even help you make the circuit and even make the circuit for you in case of a really huge emergency. If you have a kind of, I'll ship it right to your house. You should definitely check it out. So let's get started with the video then. So the things required for our today's project are a LED. You may use any color LED, a on-off switch, a terminal block, and now this terminal block is also totally optional. Resistance, I'm using these two resistors over here. So this is a 270 ohm resistor. So 270 ohm resistor. So, and now this will actually vary according to which power supply you tend to use. If you use a higher voltage power supply, you will need some different resistor, and you will need to do the calculations according to your power supply. If your power supply is lower or higher voltage, you will need to recalculate the resistor. And over here I have a NPN type of transistor. I'll try to zoom in and show you guys the exact number. So as you can see over there, TCNL 639LS. That's the exact number of it. But you also may use any NPN type of transistor, and this is also just a random NPN transistor that I had laying around, which I'm using. So then we also need a PCB board, and then a soldering iron. And if you are actually making this project at your home indoors, you will actually require a fan with like a filter on the other side of it, because the fumes that are released while soldering can be really dangerous if you inhale them. So if you're doing them indoors, kindly actually first of all not to do this indoors. I'm in a really ventilated room, that's why I'm doing this. And second of all, if you're even doing it outdoors, I do recommend using at least a fan, so all the fumes which are released can at least go away from you. So we are also going to be needing the soldering wire. So generally you are also going to be needing soldering flux, but this is a special type of wire. It has soldering flux inside of it in its core, so otherwise you will need to buy that separately. And also we are going to be using this cutters to cut all the excess wire. And over here I have my power supply. This is a 12-volt adapter, and I also have already made the schematic diagram over here for today's project. You can actually pause the video right here and click a screenshot of it. so it would be really easy for you guys to actually make it. So now I'll actually set my soldering iron on so it can get warm while we actually place all the other components inside of our PCB. So now I have plugged in the soldering iron over here, and meanwhile it's heating up, we'll actually place all the components in our PCB board. So I'll actually do this while also taking a look at the schematic diagram, and if you don't actually know how to judge all of this kind of stuff and make the PCB, I have a video on my YouTube channel. I will definitely link it down below in the description, and you can go watch it at the end of the video. So now first of all, as I have my diagram placed aside. I'm sorry I couldn't actually get that in the frame, yeah, I'll just place all the components in it, and I'll probably speed this part of the video up so I don't waste your guys' time. So now, as you can see, I have placed almost all the components except the switch over here, and the reason why I couldn't place it in, as you can see, the alignment of this is not really working out with the holes on the PCB. So what I actually need to do now is, in a switch like this, okay, so all this end one pin and that end pin are actually just for the support, so it doesn't wobble around and actually break. So we are going to be needing those support pins so we don't actually break the switch. So as you can see over here, there are 3 pins in the middle, 1, 2 and 3. As you can see, I'll try to pinpoint it using a pen. So as you can see, 1, 2 and 3, those 3 pins. So for a switch you only need 2 pins. So you will in a switch like this, you're always going to be needing the center pin, and you can cut off either one of the other pins if you're just using it as a on-off functionality. So I'll cut this side of the pin off. So as you can see, now I only have 2 pins remaining, and now it should be easier to actually place it in because I can bend these pins and try to make it align with the PCB. Okay, so now the problem which I'm facing is I can't really get this pin inside the 0 PCB. So now what I need to also do is cut that pin off. Ideally you do want to actually have these support pins in because it will help that you don't accidentally actually break the switch off. It really helps the component, but there was no other way to doing this for in my case, so we'll just have to work around with this. And the support pins are usually a bit thicker than the other pins, which are actually useful for the connections, so that's a way to spot them. So as you can see right now, I can't actually place it in still because the problem which I'm facing is that this pin over here is a bit too thick to go inside the 0 PCB. So what I'll be doing is I'll be using this blade and kind of just work around my way and make one of the holes a bit bigger. So as you can see, I'm just kinda like drilling inside of it using this plate. So, and just be careful while using a sharp object also. Be sure that you have an adult around while doing these projects regarded with electricity, because these projects can be dangerous sometimes. Okay, so now I just need to actually trim this part of uh, the switch a little bit more. Okay, so what seems to be problem over? Okay, got it. So as you can see, I've got the whole uh, uh, the support pin out now, so it should be pretty easy to place in now. Yeah, got it. So now first of all, what I'll be doing is just securing down all the components using a soldering iron over here. And as you can see now over here, I'll just try to show you guys. As you can see now, it's taking out those fumes because it has heated up now. So now I'll actually plug in our fan and use it so I can get all the fumes away from me and they don't actually come towards me. Place the fan over here, get my soldering station over here, and the soldering station is also totally optional. If you will be building just a couple of circuits, it's not worth buying according to me, but if you will be doing a lot of making a lot of circuits, then it is definitely a good investment. So as you can see, all those fumes which just got released while I literally just touched it. I'll show you again. You can see over there, and if I do it in front of the fan, then see what happens. The fan sucks all of it and throws it away from me. Okay, so I've got the LED secured now. I'll try to zoom in for the transistor so I can show you guys what exactly I'm doing. I'll move that pin out of the way. So you see these 3 pins over here, those are pins for the transistor. And I do apologize if the camera is going out of focus sometimes, because I do have to actually pay attention to the circuit, and sometimes I might not actually pay attention to the camera, so I'll apologize if that happens sometimes. Okay, so now I've actually secured it down, so I'll be doing the same thing for all the other pins, and I'll speed this part up of the video. So now I have actually secured down all the components, so now we'll be actually making the main connections. So as you can see now, no component is like coming out or anything. As you can see, the switch is also pretty secured over here. LED, transistor, resistors and all that. So now these 2 pins are coming from these 2 resistors. I will combine them over here, and I will just combine them and bring it to one singular pin over here, just like that. So what I'll be assuming is this pin over here will act as my positive pin. So that pin we can see is this side, this will be my positive. So now I'll be soldering this down also, and I'll again speed this up. Okay, so I have done that now. So these two resistors, as you can might even able to see in the shadow over here, these two resistors are now connected over here, as you can see over here in the shadow also. So now I do remember that this was a negative terminal, and if by chance this also happens with you that you don't remember which was a negative and which was the positive, just straighten the pins out, and the shorter pin will be your negative. But I already do knew that, so we'll be actually connecting this terminal over here, and then bring it in, bring it over here, and then okay. So we might have a problem over here, which just noticed. If we connect it over here and use this path to bring it over here, it will bring us over to the positive side, but we need it over to the negative. So now what I'm going to do is just actually bring it to this side, so it can go straight to the negative part. So I'll just bend it in a way that I can bring it as close as possible to the this track. So as you can see now, I have got it pretty close to the track now. It's almost touching the track over here. So now I'll be soldering that down too. Okay, so now as you can see, I've got it connected to the track over here. So now the track is coming all the way from over there right to the negative terminal. So now in order to connect it to the negative terminal, I have to just make this short path over here, and you do usually need a wire to do that, but I'll be using a trick over here. So you see this terminal of the LED over here. As I know, I'll be just able to bend this NPN terminal and connect it to the battery, sorry, the LED. So I don't need this longer wire over here. So I'll just cut that wire just like that, and I'll use that wire to actually make a connection over here. So now I've got that connected. So now the thing left to do is I'll just have a look at my schematic diagram over here. So now I can see that one side of the NPN, this side, okay, the one with the switch is coming, the switch is over here, the NPN. So yeah, the center pin, the center terminal pin will connect to this part over here. So the switch part, as you can even see in the diagram, that. So I'll be doing that now. Okay, so now so we don't get confused anymore. I'll just actually with a pencil mark this terminal as a cross, because I know that terminal is of no use. It's just for the support of the switch, so I don't actually accidentally use that terminal. So this will connect over here. So now I'll do that. So now as you can see, I'm done connecting the center terminal to the switch, like over here. So now what I need to do is bring this wire over here and connect it to this terminal. So I've got let me see, yeah, this wire right here, yeah. So this wire right here goes straight to this terminal, just like that. So as you can see, now I'm done doing that. I'll cut this access part off. So now also made this connection over here and this connection over there. So now we need to make a connection from over here to the positive side of our LED. So this over here is a positive side, and we need to connect from over here to over there. So again I'll be using this scrap piece over here to connect it. So never throw out the scrap pieces, as you can use them to make connections instead of wasting some wire. So as you can see over here, I've made that connection also, this connection right here, and the negative connection we have already made. So we are left with this one right here, this, as you can see. So this goes straight to the negative, yeah, negative, no, yeah, is it the negative? Yeah, it's the negative side. Okay, so now as you can see, I need to bring this terminal over there. So I'll be needing some insulated wire, so I'll just go and get some. So now I've got my insulated wire over here, so I'll just strip some of the wire from one side, and from the other side I won't be actually doing it because I'll be measuring exactly how much I need. So I'll be connecting this wire right there, just like that. So now I've got that wire connected, as you can see. And always actually make sure that your connection is in like tight spaces like this, that it's not touching any other wire. So I'll even zoom in. Yeah, now I can see that it's not touching any other wire. So I'll just cut this excess part off. So now I'll need to actually I could have just actually cut the wire from over here and just connected it. It would have been the easy way, but I'll be just using that much of insulated wire, because if I would have connected it like this over here, all this loose wire, there was a chance that over time this will actually like break by actually accidentally rubbing against something else. So I'll be just actually cutting the wire over here and then stripping it down from over here. Okay, so I've got that stripped, so I'll just connect that wire real quick. Okay, so I've got that wire connected now, so I'll use this scrap piece over here to make the connection from over there to over here. So now I'll double check that none of the wires are actually touching each other, and they are not. Yeah, they are not touching each other, so it's perfectly fine now. So now the only thing left to do is I have to actually bend it in a way that I don't touch this first terminal, as we actually marked it as not useful, because it for the support terminal, as you can see, the first terminal. So I'll zoom out and I'll try to bend in a way that I can avoid touching that first terminal. So yeah, so I've got it now. So I'll trim off the excess. Yeah. So I'll be soldering that down real quick. Okay, so now I have got that connected also, and again I'll do the same thing. I'll zoom in and see if it's touching any wire or not. So no, it's not touching, so it's perfectly fine. So now this is also optional, by the way. I'll be tinning this part so I can reduce the resistance or any voltage drop that may occur while using this circuit. It to be honest, there shouldn't be any voltage drops, because this is a really short distance first of all, and then we are not using that high voltage or high ampere current. So but I just like to do it because this copper film is actually really thin, so if it gets scratched like that, I won't actually do it over here. It can actually break the circuit, so I always like doing some tinning over this track. So now, as you can see, I have also done that, and you should actually do that because it is really helpful, but again it's totally up to you, but I do recommend doing it. So now our circuit is ready for us to test. So now let's actually test the circuit. First of all, I'll remove the plug of the soldering iron, and be safe while doing this, and make sure that you have an adult nearby when you are doing any experiment like this. So I'll connect my power supply in now. So I've got my power supply in. So now I'll connect these terminals. So as we discussed earlier, this side is a negative side and this side is a positive side. So I'll be doing the same. You connecting the positive to the positive and the negative to the negative. I'll just adjust my camera because this isn't really that long wire. So this is the positive. Okay, so now actually I also do need to unscrew this so I can actually clamp it down. So I'll just go get a screwdriver. So I've got my screwdriver over here. So I just need to loosen this up. So now we can connect our terminals. And this doesn't seems to be working. I think, yeah, it doesn't seems to be working. It isn't actually making that good of a connection. So what I will be needing to do is I'll use this scrap piece of wire over here. I'll just make two halves of it. I'll strip both the ends down. Okay, so I've got all the ends stripped down. So I'll place this wire in the terminal, screw it down. So okay, now I've got the wires connected. So now all left to do is that you just need to connect this wire to a positive terminal and this wire to a negative terminal, and our circuit should be ready now. Yeah, it is. So now we'll actually verify this by using the truth table. Okay, so I've made the truth table over here. So this is what we are actually told in our books and in our schools. So according to this, when the switch is turned off, we should get a glow on the LED, and when the switch is actually turned on, we will not see any glow on the LED. So according to this, like right now I have actually by the way disconnected the power supply. So right now, as you can see over here, I have it in a off position. The switch is in a off position. If I would have just made a normal circuit without any transistors or any all this complex circuitry, the switch would have actually turned off right now, but it is also off right now. As I told, the power supply is cut off, and when it would have been in this position, now both of these two terminals shorted in the inside the switch, and the LED would have turned on, but it will turn off because we have all this circuit over here. The transistor is basically taking all that current and throwing it back into the negative terminal, and that's why I can't show this on camera, but you can take my word, this resistor on the side is getting really warm to touch. I wish I could actually show it to you, but I unfortunately can't. I'll actually try to show it to you by using a thermometer, which I've actually made myself. So I'll just pull out the thermometer over here. So this is a thermometer which I made. So I use a Arduino Nano. Yeah, is it a Nano? Yeah, it's a Nano. So I used a Arduino Nano, and this is a thermometer. So I'll try to get the readings and show you that this resistor does get really warm because the transistor is basically shorting the terminals. But first, let's just actually see if this truth table is even correct or not. So I have turned on the power supply now. So the switch is in an on state. I repeat, the switch is in a on state. These two terminals are getting shorted right now, but the NPN transistor is throwing all that current back into the negative terminal, and this resistor is getting really hot to touch. And now I'll turn the switch off. I repeat, I'm turning the switch in a off position. Boom, the LED glow up. So as soon the switch was turned off, the LED glow up. So that means that our circuit is working. And as soon I turn the LED on, we don't see any more glow on the as soon I turn the switch off, we don't see a glow on the LED. So now that means that this is also correct and this is also correct. Right now it's in on position and the LED did glow. So it is in a 0 position, the LED. So now the switch is in a 0 position, which means it's turned off right now, but the LED glows up, which means this is also correct. So now I'll be switching over to my computer and showing you guys that this is actually warming up really much. So now I have switched over to my computer to show you the temperature reading. So what I have done over here, from over here I have the wire coming out straight into our Arduino Nano board, and from the Nano I have the temperature sensor connected, and this temperature sensor is currently giving a reading of approximately 30.62. Yeah, it keeps on actually giving the new reading out at the bottom. So all you need to do is just look at the bottom reading, and that would be the latest reading. So I'll try to set up my tripod over here so you guys can clearly see the last reading. Yeah, so that last reading down there that you see is a reading. So now what I'll be basically doing is I'll touch this probe onto a resistor over here, and on the computer you'll see the temperature rise. So what I'll be doing is I'll be putting I'll be first of all okay, so now it's in off position. This isn't heating up. Yeah, it isn't heating up at all. There is some mild heating in both of them, but overall it's not much. It's just mildly warm. Yeah, the transistor is also mildly warm. Yeah, no major heating. So now as soon I turn the switch on and the LED is turned off, now I'll connect this touch this probe over here, and on the computer you'll slowly see the temperature rise. So as you saw over there, from almost 30 degrees it has already gone up to 33 degrees. It will be slowly keep on rising and rising, because this is a huge probe compared to the small resistor. So already 34 degrees, and I don't also actually want to damage circuit over here, so I'll be turning it off now. Yeah, it will keep on rising and rising, and it hasn't even got warm. The probe hasn't even got warm yet, and this is like almost too hot to touch. I accidentally touched my finger. It almost burnt my finger. So yeah, so now the temperature will slowly go down. So thank you for watching the video, guys, and if you like the video, make sure to hit the like button, and also share this video, since it will help spread this knowledge to the world. And I also gave a sneak peek at my PC, which I also mentioned in my last video. So that was the water cooled PC which I was talking about, and we'll be doing a water change really soon. And disclaimer, I had actually turned off the LEDs of the PC, the RGB lighting. I only had like 2 LED strips turned on. I had turned off all the other lighting. so I didn't actually wanted to give away the surprise. I wanted to keep it a surprise for the next video. So it will probably be next month, next to next month, or maybe in the ending of the next month. I'll do a water change on the PC. So we'll be actually disassembling the whole PC down. So definitely let me know if you want to see that video. uh, Let me know in the comments down below if you would like to see the whole video in form of like a live stream, or in form of a normal video. uh, in a normal video I'll try to cut it down to around 1 hour, but it will at least be around 1 to 2 hours. I mean, I will try to cut down and make it as short as possible. But let me know if you want to see a live stream or if you want to see a normal video, because it will be a really long process, because I will have to disassemble the whole PC. Uh, and because I actually did a mistake last time when I was building the PC, that's why I will have to disassemble the whole PC now. So I won't tell the mistake right now. We keep that also a surprise, and I will let you know when we will be actually making that video. So once again, thank you for watching the video. Bye bye.